Hello, everyone, and a very, very happy new year to you. We are kicking off this year with a deep dive into something that's, frankly, set to define the next decade of pharmaceutical R&D. We're talking about a huge operational pivot, moving way beyond just digitizing old processes and into something truly transformative. You see, the era of just collecting mountains of data, that's over. The real challenge, the next challenge, is creating what we're calling a digital thread. Think of it as a way to finally unify all that scattered, fragmented data to power intelligent AI that's not just smart, but actually ready for regulators. The goal? To transform R&D into a single, high-efficiency engine. So what does this digital thread actually look like in practice? Well, in this explainer, we're going to break it all down. We'll start by looking at the staggering cost of our current disconnected system. Then we'll introduce the digital thread as the solution, dive into the technical backbone it needs, see how it puts patients first, and finally cast our eyes to the future of preventative medicine it could unlock. Okay, so let's start with the core problem, because it's a big one. And this isn't just some technical glitch or an IT headache. No, data fragmentation is the single highest tax the entire pharmaceutical industry is paying right now. And you pay this tax in wasted time, wasted resources, you name it. When you have all these disconnected data flows, your teams spend an unbelievable amount of time just trying to figure out what's real. And here's the bottom line. You simply cannot build trustworthy AI on a broken data foundation. It just doesn't work. And the numbers that show just how much this is costing us, they're staggering. I mean, get this. Global clinical trials are still struggling big time with recruitment. Less than 56% of them actually hit their target for patient enrollment. And that inefficiency, it has a direct and pretty massive impact on timelines. We're talking about a median delay in trial completion of over a year, 12.2 months to be precise. Now, what does that mean for a new therapy that patients are waiting for? And this is where it really hits home. That delay translates into an opportunity cost of about $500,000 per day in sales you're not making. This daily tax isn't just about revenue, it's about losing the race to market for a therapy that could be saving lives. It's a huge strategic risk. So clearly, the answer can't just be buying another piece of software. It has to be a whole new framework. And this is where the digital thread comes in. Think of it as the connective tissue for modern R&D. The digital thread is really designed to pull three critical requirements together. It's the operational concept that finally turns all those disconnected, expensive handoffs into that one unified engine we've been talking about. And this whole thing is held up by three absolutely essential pillars. First, a solid technical foundation. Second, the ability to meet regulatory demands for AI you can actually explain. And third, the strategic use of global patient diversity. And make no mistake, if any one of these pillars fails, the entire thread just snaps. Okay, so let's get into the how. How do we actually build this? Well, the biggest challenge we're up against is overcoming years of what you could call data debt. All that messy, inconsistent data we've just been dumping into passive data lakes. You know, to build trust with regulators, with doctors, with everyone, we have to make a decisive move away from these black box models that just spit out an answer without showing their work. We need to move toward glass box systems, where every single insight can be fully traced right back to where it came from. And this example shows exactly why that transparency is so important. A big review of AI models for predicting blood clots, which is a major patient safety issue, found that internally, these models performed great. They got a C-index of 0.84, which is a really strong measure of accuracy. On the surface, that's an A+. But, and this is a really big but, a deeper analysis showed that a whopping 87% of those models had a high risk of being totally unreliable. Why? Because they simply fell apart when they were exposed to messy real-world data, mostly because they had zero external validation. The digital thread has to enforce that kind of rigor right from the very beginning. Because if we don't fix the state of fragmentation, we just keep paying what we call the manual data tax. There was a study that used AI to detect autism spectrum disorder, and the actual training of the model, incredibly fast. We're talking a few seconds. But here's the killer bottleneck, the image preprocessing. Just cleaning up and structuring the data so the AI could even use it took up to 2 hours for a single image. You just can't scale that. It's impossible. The data flow has to be automated and structured from the get-go. Okay, so we fixed the data pipeline. We have a great engine. But a great engine still needs a clean map to follow, right? And right now, that map, the clinical trial protocol, is often full of roadblocks and detours, putting a huge burden on the sites, the staff, and, of course, the patients. The key here is a total shift in mindset. A protocol can't just be a static PDF anymore. We have to start using the digital thread to create living, breathing protocols. Protocols that are constantly updated with real-time data, that remove redundant steps, and that reduce the burden on absolutely everyone involved. And you can see this friction perfectly in a study on e-consent for rare disease genomics. The standard, off-the-shelf digital process, an uptake of just 18.6%. But when another group used targeted, clear communication, where patients were actually involved in the process, they hit a 94% consent rate. The lesson couldn't be clearer. You have to design the system for humans. All right, now let's zoom out and take this to the global stage. The lack of patient diversity in R&D isn't just an ethical checkbox. It is a major strategic risk. Actually operationalizing global diversity is a critical asset for building better, safer medicines for everyone. Let's just take sub-Saharan Africa as an example. Right now, the region only conducts about 1.1% of all global clinical trials. And yet, the sites that operate there report better performance, with amazing retention rates, often over 90%. It is a hugely untapped source of crucial genetic diversity and high-quality data. So how do we tap into this global data without compromising privacy? Well, the answer is a really clever approach called federated learning. Instead of moving sensitive patient data around, the AI model itself travels to each hospital. It learns from the local data right there, behind their firewall, and then only sends the insights, not the data, back to the central hub. It's the best of both worlds. You get global scale and rock-solid security. And the ultimate payoff, the grand prize for getting all this right, the structured data, the AI, the precision medicine, is something truly game-changing: opportunistic screening. This is where a routine CT scan or an MRI, for one thing, can start revealing other diseases and risk factors before you even have symptoms. It completely moves the entire focus of medicine upstream. You see, investing in this digital thread today is really an investment in preventing catastrophic failures tomorrow. It's about building the foundation for a future where R&D is proactive, not reactive. And that leaves us with a pretty big question. As we finally start to unify our data, are we truly ready to shift the entire focus of medicine from treatment to prevention?